What's up, guys? Welcome to another live learning session. So we just recently have been exploring convolutional neural networks in PyTorch and um, KFold validation. One sec. Um, in this one, we're going to test some. Uh, we're going to train a neural network, a convolutional neural network, with KFold validation, and we should be getting better uh, accuracies than we did before. And for reference, I screwed things up. Okay, for reference, we got around 84.4 accuracy with the convolutional neural network. Um, geez, what do we get here? I think we had 70 something before. It is in one of the former videos. I've forgotten what it is. Anyway, we're going to get all of our stuff that we need. So I should just make this like this is the import block, and I should make it like non-verbose or something, because this is like, I don't even know, like it's missing a symbol. Um, anyway, then we're going to use the neural network that we've been using. I'm going to use this one, the basic forward loop. We're not going to print out the size. We don't need this. Here's how we create the model, so that every time we create a new model, we'll be fine. So actually, I'm going to separate this from the. I'm going to put this into the same loop as this. And I'm going to put this one here. So this one actually loads and unloads the data, or not unloads. This one loads the data, so it doesn't need to be in the same one as this. This is what resets the neural network, so we want that to be together. Now we're going to define. Yes, okay. This is where things get different. So now we're going to go and we're going to create. If you want to see an explanation on how this stuff was written, I would recommend checking out the former videos that I can post in the comments probably, or description. Anyway, we're going to check out how do we train this stuff. So first we're going to import, from sklearn.model_selection, import KFold. So remember, we're doing KFold validation, which we just looked at. And we got to understand how KFold works, right? So we're going to create a KFold validator. We're actually going to use this one because the shuffle, I like the shuffle. It gives you a data set. It gives you more opportunity to play around with your data set, and the random state allows you to control and make it reproducible. So now we basically want to do this, but we want to make it train the model instead of just print out the indices. So I'm going to get rid of that. We're going to train the model now. So we want to be able to get a subset sampler. So we're going to need to go and get a train subsample. This is actually going to be a generator, I think. Is subset random sampler a generator? Random sampler, a generator. I'm looking this up on the fly. Random sampler. Yeah. Pretty sure this is a generator. Yeah, okay. So torch dot utils dot data dot random sampler. Here we go. And we're going to get the training indices. So that's going to be the training one, and now the validation one is going to be the validation indices. Subsampler. random sampler, validation indices. Okay, so now we have our train and validation indices. What we want to do is we want to get the data loaders, which earlier we created here. This is our initial data loader, so we actually don't need these. Might as well just get rid of these now. But remember, we need the batch size to be 64 still. So train loader, train data loader equals torch.utils.data.data loader. And here we're going to do the data set, which, what do we call training data? That's training data. And then what else do we need? The batch size 64 equals 64, which we could actually just say batch size equals batch size. I don't know why we need to do that. But sampler was train sample. There we go. And then the validation data loader. Do you guys hear? Oh, I think that's what that is. I don't know if you guys heard ringing earlier, but there was some sort of, I think I'm like hitting the keys too hard or something. No. Training data batch size equals 64, sampler equals validation subsampler. Cool, so that should give us the neural network that we have, and we're going to use the model that we have created earlier. And the optimizer, and now what we should do is we should basically do this thing. This should be train data loader. And then we should do this thing. So we should actually just, I think we can actually just completely copy these functions. So let's define this. Define this as KFold training, KFold train validate. And then here I'm going to add some code. I'm going to add the train loop. That's not right. That's the max pool formula. Where'd it go? And I'm also going to add the test loop. So this one gives us our accuracy. This one trains the model. So what we want to do with our CNN exploration is basically do this. But with K-folds. I got this like mango bubble tea. I'm pretty sure I just got this like mango thing in my mouth. That's kind of strange. I'm actually going to put these in the same thing. No, that's not what I wanted to do. Here we go. Yeah. We're going to pass in the data loader. Train DL, test DL. DL. Okay, cool. Okay, now that looks nice. Now what we're going to do is we're going to optimize loop. How did I call this? Epic list. And we're also going to plot this stuff. So we want to be able to plot this over time. Where did I? Huh. So for every time, every fold. Wait, this doesn't look right. Let me think about this. What we should actually be doing here is we want to be using this, but we don't want to retrain the model each time we run a fold. We want to reset the model each time that we run a fold. So we might need 3 loops for this. I'm going to think about this. I'm going to pause here. I'm going to think about this for a second. Okay, so here's what I was thinking about while I was gone. We need to save the model after we test each fold because that's the whole point of having KFold validation. But we also need to reset the model every time we do KFold. And what I've done before is basically just initialize a new model. So I think what we're just going to do is just reset the model. So we're just going to take a new model and reset it after the optimize loop. And we actually only need to reset the model in the optimizer. But the optimize loop needs the plot x, plot y. What else do we pass to it? And the number of epochs. So I'm actually going to set these here, right here. Epochs, we're going to do just, I don't think it got, let's do 25 epochs. So now we're actually going to be doing 125 training epochs. So I'm going to pause this for like 10 minutes and then come back. And then, oops, what did I call it here? The training DL is going to be the train data loader and the test validation. Test data loader. Oh, it's just validation data loader here. Validation data loader, and then the optimizer. Optimizer equals. So that's what the optimized loop will look like here. We're also going to have to save the model. So PyTorch does allow us to do this. So what we're going to do is we're going to torch.save model.dict. Is there a dict here? State dict. Wait, do I get the, yeah. And then this is going to be dot slash KFold CNN KFold. Okay, well, let's call this the Fashion MNIST CNN fold. And I think I have to save it as a dot something. What is PyTorch? What are PyTorch Models saved as. Saving and loading inference for models. Okay, cool. .pt. .pt. Cool. And then, oh, we should also import matplotlib. Yep, didn't think about that one. Probably want to import it here. We already imported this, so technically we probably just want to import it separately, but it doesn't matter. No, let's actually, let's do this. From matplotlib dot plot pyplot. No, wait, import pyplot as plt. There we go. Now we want to plt.plot, plot x, plot y, plt.show, plt.savefig, fold accuracy .png. And I think that should be fine. And then we just call KFold train validate. Oh, whoops. Let's see if this works. Let's make sure this works first. Man, this is some pretty crappy. No, this is not working because this is the same as last time. Okay, let's go figure out what's going on. Okay. I think it was the optimizer, but I could be wrong. Ooh. That's kind of weird here. I think we're getting nearly the same, so something's wrong here. Is it because I'm setting a new optimizer here? No, that should be the same. Let's look at this in the text editor just to see. These are not the same, but they are quite bad. Huh. It was not this bad before, so I don't think this is correct. It should not be this bad. Am I running this incorrectly? Train DL, test DL. Data loader, okay. This is out of 60,000. This is not out of 60,000. It actually should not be out of 60,000. Should it be? No, I don't think the data loader I'm passing is correct. Here we go. Yes, okay, that's right. No, that's right. Train, data loader, validation, data loader. No, that's actually... that actually should be right. Alright, so we're going to figure out how to debug this. Oh wait, we should stop this one. This is ridiculous. Okay. This is kind of crazy. I messed this up. I shouldn't have had it print out so many things. Okay, let's go back here and let's fix this first. Let's okay. Yeah, so this conversion is much quicker. What was going on here? This should not be training 60,000 because in a set with this we should have 48,000. So I think the data loader here. Here I give them the train data loader and the test data loader. Here I give train data loader and the validation data loader. I'm gonna pause while I try to figure this out. I don't want to make this forever. Okay, so I've reset this notebook, and the best I can figure out what's going wrong is I'm using the subsampler wrong, and I can't like on the fly fix this, so I might take another video for that. But what we can do is we can actually just pass in different training data. So what we're going to do here is we're going to get rid of the subsamplers. And what I'm going to do is training data subsampled. How about this? Subsampled is equal to training data, training indices. And subsampled validation data equals training data, validation indices. And we're just going to put that here. And I'm just going to put that here. And we're going to check this out. Oh, that doesn't work. Only one element tensors. So I screwed this up again. How did we do this last time? We did a stack. Here we go. Stack training data x for okay, wait. Let's see what the training data looks like. Training data size. Okay, wait. I'm gonna do that here. Training data dot size. Oops. Fashion MNIST. Okay. Dot. Okay. Torch dot data dot utils. Torch dot. Where is this? Transforms. Torch vision. So transforms. Gosh. Okay. Transforms to tensor. Yeah, this should be. How can we look at this training data size? What do we do here? Okay, I'm going to pause the video once again while I figure this out. Okay, so I got the subset thing working. So you can't just call training data for training indices. You actually have to call this data thing, this torch.utils.data.subset. However, I'm still working on this part right here because all of the epics are repeating the models, and that is wrong, and that should not be happening. So we're going to figure out why that is, but I'm going to pause while I figure that out because I don't want you to have to like watch me sit here for another hour and like mess around with this. So let me do that, and then I'll be back and we'll talk about why it was doing that and how we figured that out. So the way I figured this out earlier, by the way, was just I just read the documentation. That's all. There's really not much more to it. Okay, I found out what the error was. So I played around with this name thing a while, but actually what the error was is that I was passing, it was that this was running on model. Um, and here I was not passing in the model to the optimized loop, and we were just using the model that we created earlier, which is this one. So, lesson learned here is to remember to pass in your changing parameters to your functions when your parameters are changing. So I let this only run for 5 epics, and we get to like 76.4, which is like pretty good. When we look at here around epic 5, we're 77. So this one's training on less data, but what we're actually going to do is compare the different validation accuracies based on the different datas. So, you can get higher accuracy by training for longer, but we're just going to run all 5 of these on 5, and I'm going to pause while they all run, and then at the end we're going to come back and take a look and just do a short comparison and commentary. Cool. So, all of the KFold validation things have finished training for 5 epics, which is clearly not enough, as we can see from these images. It's not really leveling off yet at this point. So you can see the different training graphs. They're all kind of coming around 77. So this one's 76, 76.6, 76.7, 76.6. 77.1 is actually higher than our full training, but this is pretty much just like a part of random, like the random seed. And then the last one's 75, which is a bit lower. And we saved all these models so we can come back and load them at any time. In a future commentary, we'll probably talk about loading and loading models. And we'll also look at, plotting training versus validation accuracy over time, which you want to see because then we can kind of start to see where it is overtraining. And when it's overtraining, your training accuracy will continue to go up, but your validation accuracy will no longer go up. And that will probably take a lot of epics. So that'll definitely be more pausing and starting like we did this time. So yeah, thanks for watching. Make sure you subscribe. Peace out, and I'll see you guys next time.